So let's try to solve this question. This question says that calculate the volume occupied by 3.5 gram of oxygen at 27 degrees Celsius and 740 mm pressure, and the atomic mass of the oxygen is also given, which is 16. So when you see this question at first point, it seems very simple. That's yes, the mass of the oxygen is given, which is 3.5 gram. The atomic mass of the oxygen is given, which is 16. So we can calculate the gram molecular weight, which is 16 to the 32. And we need to calculate the volume. So we're gonna use the first and the second formula, and we'll get the volume, because we know the mass, we know the gram molecular weight, and we know the like 22.4, which is definitely a number. So we just need to calculate the volume in liter, and that's it. This question is finished. But now, if you do this, you're gonna get that a volume at STP and not at the given condition, which is 27 degrees Celsius and 740 mm pressure. Okay, so sir, if this is the given condition, what is STP? So definitely STP is 0 degrees Celsius and 760 mm pressure. 760 mm of Hg basically, which is mercury. Okay, so this is the condition for the STP, and whatever given over here is at a given condition. So when you're gonna use this for two formulae, when you will equate the mass upon gram molecular weight is equal to volume in liter upon 22.4, you're gonna get the volume at STP and not at the given condition. So in order to calculate the volume at given condition, we're gonna use the gas equation. So let's start this question first, and then we'll see that how can we calculate the volume at given condition, which is 27 degrees Celsius and 740 millimeter of pressure. So let's start. So answer. So let's calculate first of all the volume at STP. So mass is gonna be the 3.5 gram divided by gram molecular weight of oxygen. So how do we get the O2? When we add one O plus one other O. So O plus O gives us O2. So 16 plus 16 is gonna give you 32. So gram molecular weight is 32 is equals to volume in liter, definitely at STP, is divided by 22.4. So when you solve this fraction, volume in liter as STP is equals to 3.5 into 22.4 divided by 32. When you solve this part, you get the 2.45 liter at STP. So volume in liter at STP is gonna be 2.45. Okay. Now, what is the next step? The next step is the gas equation. What is the gas equation? So gas equation is P1 V1 upon T1 is equals to P2 V2 upon T2. This is the gas equation. Okay, now we are having two conditions, one at STP and another which is given condition 27 degrees Celsius and 740 millimeter pressure. So let's divide these two into two parts. The P1 V1 and T1 are gonna be the pressure, volume and temperature at STP, and P2 V2 and T2 are gonna be the pressure, volume and temperature at given condition, which is 740 millimeter pressure and 27 degree Celsius. Okay, so sir, do we know the P1? Yes, we know the P1 at STP is 760 mm. Do we know the V1? Yes, we just calculated, which is 2.45 liter. Okay, so 2.545 liter and 760 mm Hg, and temperature T1, yes, we know 0 degree Celsius. Oh, but we cannot divide any fraction with 0, that in denominator it cannot be 0. So definitely we are not gonna use the degree Celsius. So very important point when it comes to solve the gas equation is that pressure has to be in the millimeter and the temperature has to be in the Kelvin and not in the degree Celsius. Okay, so basically we have the degree Celsius. So what should we do? We should convert this into the Kelvin. Okay, so how can we convert into Kelvin? So basically whatever temperature is given to you, just add 273.15 and you'll get the temperature in Kelvin. Okay, so sir, if 0 degree Celsius is given to me and I add 0 plus 273.15, then answer is gonna be 273.15 Kelvin. Correct. 0 degree Celsius is equal to 273.15 Kelvin. That's it. So now this is the temperature at STP. Okay, so we know the T1 also. Okay, do we know the P2? Yes, it's 740 mmHg. Okay, V2, that's the V2 which we have to calculate, and the T2 is 27 degrees Celsius, which is given. Again, we cannot use the degree Celsius. Then what should we do? Correct. Just add 27 plus 273.15 and you'll get the temperature at Kelvin. Okay, so 27 degrees Celsius is nothing but the 300.15 Kelvin. Okay, now out of 6 quantities P1 V1 T1 P2 V2 T2, we know the 5, so we can calculate the sixth one, which is volume at given condition. Okay, so let's fill first of all the data. So P1 is gonna be 760, V1 is given 2.45 divided by T1 is gonna be 273.15 is equal to P2 is gonna be 740. V2 we need to calculate, which is the given condition, volume at given condition, and the T2 is gonna be 300.15. Okay, now let's put all the number on one side and V2 at other side. So V2 will be is equal to 760 into 2.45 into 300.15 divided by 273.15 into 740. When you will solve this calculation, you will get the volume V2 is equal, we'll get the V2 is equals to 2.76 liters. So this is how we calculate volume at given temperature and pressure which is not equal to the STP condition. Okay, so whenever we are provided with the temperature and pressure outside the STP condition, what do we have to do? We have to first calculate the volume at STP. They might ask you the temperature STP or they might ask you anything other thing, but first you have to calculate the volume at STP. Then you have to equate the equate this equation P1 V1 divided by T1 is equal to P2 V2 by T2, and then you have to solve for the given condition and you will get the final answer. I hope you understand this question properly. Okay, and if you still have any other doubt, you can comment in the comment section and we'll make a dedicated doubt solving video for your doubt.